Right, this is 5.5b, solving logarithms. Okay. Anytime you see a variable in the exponent, you should think logarithm and power rule. So I take the log of both sides, and you can take any log you want. You could use the log, you could use ln, you could use log base 6, but I would choose one that your calculator has, like the log or the ln. I choose the ln because it's shorter and I'm lazy. So that allows me to take the x minus 2 and stick it out front. That's the power rule. So x minus 2 times the ln of 25 is equal to the ln of 125. Divide by the ln of 25. So now I have x minus 2 equals the ln of 125 divided by 25. And we add 2. So x is ln 125 over 25 plus 2. Let's pull up our calculator. ln of 125 divided by the ln of 25 plus 2, 3.5. Any questions on that? Use a calculator. So if it's a, so he's asking ln 125 and ln 25. Normally no, but this one, if we went backward from the change of base formula, it would be log base 25 of 125. So 25 to what exponent is 125? And the answer is 1.5 or 3 halves. So usually you can't do that in your head, but these problems end up usually being a fraction. So how do you go from 25 to 125? You take the square root and then you raise it to the third. So the square root of 25 is 5, and 5 to the third is 125. But you won't always be able to do that. All right, let's do another one. Okay, same idea here. ln both sides. So the ln of 64 is equal to x minus 4 times the ln of 32. So we divide by the ln of 32, and then we add 4. Is that one you can do in your head? How do we turn a 32 into a 64? You would have to do the fifth root. The fifth root of 32 is 2, and then 2 to the sixth is 64. Yeah. So that one you kind of can do it in your head, or just plug it in your calculator. So ln 64 divided by the ln of 32, and then we're going to add 4 to our answer. 5.2. Okay. Let's change gears just a little bit. Oh, that's not what I wanted. I wanted this. Okay. A loan of $28,000 is made at 4% compounded annually. How many years will the amount due reach? After how many years will it reach $39,000? So we start with $28,000, and our interest rate is 4%, so we multiply by 1.04 to the t. How long is that going to take to reach 39,000? Well, when you're going to take the log of both sides, you have to isolate the base and the exponent. So I need to get rid of that 28,000 before I can ln both sides. Divide by 28,000. So move this over. Now we ln both sides. And that allows me to take this t and drop it out front. And I've just converted my exponential equation into a multiplication equation. What's holding the t and the ln together? Multiplication. So we divide by ln of 1.04. And in this case, you cannot do that in your head. So these two numbers belong inside the first log, and then the second one belongs inside its own log. Yep. All right, so ln of 39,000 divided by 28,000. Close the parentheses, that's the numerator, divided by the ln of 1.04. So 8.45 years. Oh, so this question is a little strange. It says, after how many years will the amount reach 39,000 or more? And it wants us to round it to the smallest whole number. So after 8 years, will we have $39,000? We won't quite be there yet, right? It takes 8.5 years. So I think they want this answer to be 9. Because 9 is the first number that reaches 39,000. So I think you're rounding up. Should we double check? That's my guess. Sometimes Alex does some weird things. 9. Yep. Okay. Because it wants to know. Yeah, so it wanted to know what is the smallest number that breaks 39,000, the smallest whole number. All right, so here we start with $24,000. That car's worth that much. It loses 30%. How do you lose 30%? 0.7, good. To the t, how long is that going to take to reach 6,500? Divide by 24,000. Good job. So now I need to get rid of the exponent. So we ln both sides. And that allows me to drop the t. Now we have a multiplication problem on the left, so we divide by the ln of 0.7. And your answer is just the ln of 6,500 divided by 24,000 divided by the ln of 0.7. So 6,500 divided by 24,000 divided by the ln of 0.7. So what are we going to put for our answer? 4. So at 3.66 years, we have reached 6,500. So the first whole number that will break 6,500 would be 4. So you're always rounding up here. Yeah. Yes, if it's 3.1, we would still round it to 4. Because 3 was not enough, it would take 4 to get there. Good question. All right. Okay, solve this. I have to get the base by itself, which it already is. So we ln both sides and drop the x minus 5. X minus 5 times the ln of e is the ln of 5. But the ln is base e. So e to what power is e? 1. And 1 times anything is itself, so the ln of e just falls out. And now we add 5. Should I write the ln of 10? No. It is the ln of 5, and then we add 5 to that. Just plug that in your calculator. Okay, let's look at another one of these. Excuse me. Again. ln both sides. Negative 6x ln e equals the ln of 8. But the ln of e is just 1. So we divide by negative 6. And when you plug it in your calculator, make sure you close the parenthesis on the 8 and then divide by negative 6. And there's no way to do that in your head. You've got to have a calculator. Okay. Same here. So ln both sides. We get x minus 5 times the ln of 7 equals the ln of 3. I can't drop the ln 7 in this case, so I have to move it. So I divide by the ln of 7. Then what? Add 5 to the outside. Now, notice what this says. Do not round any intermediate computations. Logarithms are very, very sensitive. They get their feelings hurt easily. Yeah, they're kind of like, just like Owen, right? They get their feelings hurt. And what I mean by that is, if you type in a logarithm and you round the number in the logarithm, or you round the answer and plug that into a logarithm, then your answers could be wildly off. Just due to the nature of how logarithms work. So this says don't round any intermediate computations. That means if you are solving this and you're doing it one step at a time and you get a big long decimal, plug that entire decimal into the logarithm. Because if you don't, it gets its feeling hurt and the answer could be way off. And let me show you what I mean. So let's say I had the log of 4.89, all of this stuff. Okay. And then I just did, let's just do the log of 4.8. Those are off by quite a bit, right? So what if I did the log of 0.123? And then I did the log of 0.1. Right? Those are off by quite a bit. And you can find other instances where it's even worse than that. Okay? So when it says don't round in intermediate computations, it means plug in all the decimals. Now, I'm lazy. I don't like doing that. So another way to fix that problem is don't do any computations until you get to the end, and then just type the whole thing in. That's what I do to eliminate that problem. Yeah, so ln 3 divide ln 7 and then add 5. So plug it all in and then round it here. If you round along the way, you're going to get a different answer. So whenever it says don't round in your intermediate computations, that means plug in all the decimals. Or just solve it and then plug the entire equation in at the end. And then just round once at the end. Okay. Let's do another one of these. Oh, sorry. ln both sides. Negative 3y times the ln of 8 equals the ln of 6. Now, I need to divide by negative 3, and I need to divide by ln of 8. What order should I do those in? Turns out it doesn't matter. So here are the three possibilities. ln 6 divide ln 8 divide negative 3. That is exactly the same thing as the ln of 6 divided by negative 3 divided by the ln of 8. Or you could do this. Divide them both. Negative 3 ln 8. All three of those will give you the exact same answer. Yeah. No, it's the natural log of 6. So the ln of 6 means e to some power, e to the x equals 6, right? So it's not something you can do in your head. So it doesn't matter how you type this in, but make sure that you close the parentheses on each logarithm. That will mess things up. So you could divide the ln 8 and then the negative 3, or the negative 3 and the ln 8, or if you want to do them both at the same time, just put parentheses around both of them, and you'll get the same answer. Okay? All right, last problem. Okay. So, bacteria growth. This says continuous exponential model. What equation do we use for continuous growth? The PERT. Okay, so we're starting with 1100 bacteria times E. We don't know how fast it's growing, but we are waiting for 3 hours. And after that amount of time, we have 1, 2, 4, 6. So the goal here is to figure out how fast are the bacteria growing. So we divide by 1100. Yep. Then we ln both sides. Drop the 3r. So we get 3r ln e. Oops. Ln e is equal to the ln of 1246 over 1100. Ln of e is just 1. So we just divide this by 3. So the ln of 1246 divided by 1100, maybe. And then we'll divide that number by 3. And what does that mean? What were we looking for? We were looking for the growth rate. So the growth rate here would be 4%. Okay. Let's do another one. Continuous exponential growth. So, how many hours does it take for the size of the sample to double? So y equals PE to the RT. What do I know about this? I know this is 5.8%. Do I know how much I start with? No. Do I know how much I end with? Kind of. It's double what I started with. So what do I start with? Turns out it doesn't matter, right? If you started with 8, then double would be 16. If you started with 10, then the double would be 20. So it doesn't matter what you start with. The end is going to be twice as big. So just for fun, let's say we start with 400 bacteria. How many would I end with? Oh, it's not RT. Sorry, it's going to be 0.058 T. And I would end with 800. Okay. Are 400 bacteria going to double any faster than, say, 7 bacteria? No, the double is going to be double no matter what. So how do I solve this? Divide by 400, and I get 2 equals e to the 0.58 t. Now, if I would have used 7 and 14, would this number be any different? No. If I used 100 and 200, 1 and 2 wouldn't have mattered. So you can choose any amount you want for the doubling, and when you divide, you're going to end up with 2. Now what? ln both sides. So the ln of 2 is equal to 0.58t, or sorry, ln e, and the ln of e is just 1. So ln 2 divided by 0.58. It would be 0.58, but your calculator doesn't care. Oh, yes it does. Yes it does. Thanks, Owen. 0.058. Thank you. All right, that's it. Get to work.